Okay, part B of radioactive decay. This one should hopefully be fairly quick. And we're going to look at the ionizing ability and penetration of the alpha, beta, and gamma decay, or the alpha, beta, and gamma particles that we learned about in last video. Let's get into it. Okay, let's start by talking about what is ionizing ability and what is penetration. Ionizing ability is the ability to break chemical bonds in matter and basically therefore cause damage. So something that is ionizing will basically break bonds, chemical bonds in a substance, whether that's living or non-living. This is probably most relevant to things that are living, and basically the greater the ionizing ability, the greater the damage that it can do. Penetration is the ability to travel deep into or through matter. So penetration is about how far these types of radiations can travel into various forms of matter. So ionizing radiation, that's the alpha, beta and gamma, can affect living matter in two ways. And we're really most concerned about living matter when we're talking about matter here. Higher levels can kill cells, which is basically like radiation burns. We know high levels of UV will kill our skin cells and lead to sunburn. Well, high levels of any of these types of radiation or these radioactive particles will basically lead to radiation burns. There can also be a more long-term effect, and that is that exposure can damage the DNA. So DNA is our blueprint that's inside of each of our cells. If that DNA gets damaged, those cells can't replicate and divide properly like they do for normal life, and that can basically lead to uncontrolled cell growth, which is what cancer is. So exposure to radiation will significantly increase the chances of you developing a cancer. So, what are some of the properties of alpha, beta and gamma? And in particular, what is their relative ionizing ability and their relative penetration? So alpha has a high ionizing ability. It's a big particle. It has 2 protons and 2 neutrons. It has a 2+ charge. You know, it's big, it's heavy, it's charged. If it hits you, it'll do a lot of damage. So it has a high ionizing ability. Beta is an electron, so it's much, much smaller. It has a charge, but less charge. So it's not as ionizing as alpha. And gamma is basically just high energy light. And for the most part, yes, we know light like UV can damage us, but it is nowhere near as damaging as getting hit by charged particles that have some mass. It's basically, the difference between having a torch shone on you and having a baseball thrown at you, you might say. So the ionizing ability of the gamma is low relative to the alpha and the beta. It's obviously high compared to, say, UV or visible light or something like that, but we're really just in comparison to each other. We're interested here. Compare and contrast the ionizing and penetration through matter of alpha, beta and gamma. That's what we're doing here. So the penetration of alpha, though, is very low. Because it's so big, it can't travel through matter very well. It's very easy to stop. It won't travel more than a few centimetres in air. Beta is moderate. You can stop it with some thin foil. Travel a reasonable amount of distance in air, but as I said, it doesn't take much to stop it. The penetration of gamma is very high. If you wanted to stop most of the gamma coming from a radioactive source, you'd need to have several centimetres of lead basically between you and the source. The gamma would travel straight through some foil or some thin steel or some material like that. So they are our properties of alpha, beta, gamma. Note when I talk about beta, I am talking about both beta minus or beta plus. It is basically similar in both cases. So what can you do to keep yourself safe from exposure to ionizing radiation? Well, the first thing you can do is increase distance from source. So if possible, don't stand so close to the radioactive source. Move further away. That will decrease your exposure. pretty much common sense. Second one, pretty much equal common sense. Decreasing exposure time. If possible, you minimise your exposure time to these forms of radiation so that basically there is less chance of, well, it either causing burns or causing that DNA damage. And finally, the third thing you can do is use shielding. So, particularly people who maybe are dealing with, alpha is very easy to protect from because it's got very low penetration. Any, you know, a, a, a protective suit made of thin paper or plastic would stop the alpha. The beta, then you might need to use something like, some sort of foil or something like that. The gamma, it's very hard to stop that. You need to just basically, use large amounts of lead to shield yourself from that. Even a lead apron, is probably not going to be thick enough to stop a high percentage of the gamma because the thickness of the lead that you could put in an apron and still wear it and it not be too heavy won't be several centimetres thick. It won't be sufficient to stop the penetration. I guess the good news is, though, that the gamma is the one that'll do you the least damage, but it can still cause damage. So that's it for ionizing ability and penetration. You might see here I called this penetration power. You might have picked I changed that on the first slide. I used to always use the term penetrating power. It's always the term I'd been taught and learnt, but the SACE outline is now using penetration, so I have sort of moved towards using the word penetration rather than penetrating power, but they mean the same thing. Thank you.